forgetting to record the session. So I think now it's okay. As one of the things that I was talking, it's like to give you the hint on how the report should be organized. And I think that you started by mentioning the background or introduction to the study, just giving the overview to the respondent, the logic behind, the story behind why you do this analysis. It's okay. And another thing, when you are trying to say like executive summary, don't include even the test you did. It's like telling like what we call sales pitch or sales pitch. Like sometime you can go on interview and then an interviewer ask you to introduce yourself, something like that. You know, when someone asks you, yes, yeah, it's sales pitch. It's like uh people can I can ask you to tell me who you are in just 30 seconds. This is what we call sales pitch. When you are trying to convince me, you mention something which is intensive. You mention something which is powerful for you so that I can be interested for you to ask you more about that. You know, that's how executive summary is about your report. When you are trying to make executive summary about your report, you mention something which is attractive based on the findings that you get, so that for people who read executive summary, they will be interested to read the entire document. That's why in executive summary, you try to make a short, brilliant summary of entire report. You tried, but try to add more. Try to add more so that you can be good on that. And then in the introduction, maybe introduction will be try to increase the introduction so that it can be much, like providing much information, and even you can do like some citations. I know this is dummy data, but the reason why I'm telling you to increase the introduction, you will know how you do researching, something like that. If you know how you do researching, most of the time, if you are going to do the project analysis, they will not there is no necessary to cite. It's just doing analysis and then reporting the analysis you made. But for me, the reason why I'm trying to give you that kind of assignments, I know it is somehow complicated, but through making practice, you will know how things should be look like. Yes, but okay. And then maybe you can, in introduction, by completing your introduction, you can say that we are going to look at the. Okay. Elias, I don't know the problem. Maybe you can mute your mic. So Elias, uh, Elias, so you are not serious, guys. So this guy is not serious. I don't know the problem. So let's continue, but we are going to see how we can handle it. But I know, okay. What I'm trying to say, it's about on the at the end of that introduction, you can mention something which is like explaining a bit what are you going to cover in your reporting. Maybe you can say This report is going to analyze the data to identify, as you mentioned, something like that. And sometimes you can mention the some variables that you are going to look for, or some key metrics that you are going to look for. But remember, this report, it was for the learning purpose. But most of the time reporting, descriptive analysis that we can make, maybe the report that you can submit to the boss, there is not necessary to include inferential statistic like a p-value, something like that, that's kind of. And I see that you include it, but it's okay, no problem. The objective of this, it was like having a general picture of you, how you can do those kind of things. Okay, yeah, but yeah. And then you try to continue by saying introduction, put the chart. Just make sure that you align your things properly. Align your things properly so that it can be interesting, and try to format it like using a Word document to make it readability, to make it attractive. Yeah, but in general, it's okay. So let's jump to the session of today. Like today, it was about covering inferential statistics, and then tomorrow we will continue to have a look on reporting and something which is needed. Maybe how we can use GitHub to push our project. For example, you have learned about the GitHub, and the one of the thing which is good for GitHub, it's like market to do marketing yourself. It's like building your CV, building your portfolio. You can do like a project like that, but no one knows that you can do it. That's why we need to push those kind of things that you made to the GitHub, so that anyone who want to run Python, sorry, anyone who want to run other programming, anyone who want to know how you can do reporting of the project, they can ask you help to guide him, because he really like what you do. That is the only thing that GitHub can help you to sharpen your skills, like to share your knowledge publicly. And even I will show how you can post those projects in LinkedIn, I think, as we have mentioned. So after finishing that, so we jump to the last part of building dashboard. I have a dashboard that I designed. I will show you, and I request you to follow it so that we can do the same. So allow me to present my screen, but I see new people here. I see Elias Neo Negereje. So maybe we can give him like 1 to 2 minutes, and then tell us who he is, so that we can proceed, and maybe can ask a question uh, before we proceed. Because for me, it's a first time that I see the here in this class. Maybe you can produce and then tell us why he's here. Yeah, it's okay. Time for areas if it is available. Okay, so I was trying to document some codes that is going to help us to know how we can do inferential statistics, and you know that I think you know the reason why we do inference. It's like based on the information we have, based on the descriptive analysis that we made, based on the data we have, we can decide to predict what is happening in the future. So even we can take decision based on what is happening in the future. So that's why we gonna. Okay. I don't, someone who has a question, maybe you can ask your question, because I didn't see it in my screen. Okay. Who has a question? Let's proceed. Let's proceed. I was saying that we use inferential statistics to take decision based on the current situation. So I think this code will help you to run more. So I try to generate my own data. Or I'm not the reason why I didn't use the current dataset that we have. So all of uh, I'm not sure if the data type we have it can handle all those kind of things. That's why I use dummy data, but I will find the data set that is matched to each test so that you can see how it can work. But for now, I think you have run one the what is new for you to like one sample t-test is for you. I think Benoit he covered some techniques for inferential statistics, so that's why I don't need to repeat it again. Just tell me where I can start for new things that you see in a code. That's why I share you the code of today, so that you can ask me what you didn't understand it very well and what you have, what him he's already covered, and don't not necessary to come back again because we have a lot of things to cover. So tell me where I'm going to focus. Okay. Yeah, okay, thank you. So you see, I have tried to say the purpose of using each techniques in inferential statistics and the when and how we can use it. I have tried to do it. Let's start by one sample t-test. The purpose is to test if the sample mean is a significant difference from known or hypothetical value. Let's give you an example. So let's say that maybe we have a product A, and then we know that average income of that product A is 1 million per month. That is a cost. That is the revenue. That is an income we have in our mind that if we sell product A, we earn on average 1 million. And then we want to confirm if that hypothetical value we have in our mind, if that number that we have in our mind, is it really appropriate based on the current situation? That's how uh, sample t-test can be applied. For example, let's say it in Kinyarwanda. So the reason why I'm trying to use English is because we are going to upload this video in YouTube. That's why I'm trying to mix it so that anyone who watch it, maybe they will not be stuck. But in Kinyarwanda, so the reason why we use one sample t-test, it's like dufite product A, uh, dufite product A ducuruza. None iyo product A ducuruza tuzi ko ku kwezi ishobora kutwinjiriza miliyoni, ariko icyo ni ikintu twebwe dufite mu mutwe. So turashaka gukomfaminga niba koko icyo kintu dufite mu mutwe gihura na realite zihari. Icyo tuzakora tuzajya kuri field dushaka amakuru ari related na n'iyo product A nayo yinjira avuye muri iyo product A, hanyuma dusaminge dukore mini nk'uko bisanzwe. Iyo mini nibirangira tuzayikompara na cya giciro dufite mu mutwe aricyo nise miliyoni, turebe niba bisa cyangwa se bitandukanye. That's how one sample t-test. It is when we are not sure, is when we want to compare actual value of one, when we actually it's when we focus on one group, one sample, and then we want to consider the result that we already knows ourselves to the real one. It's like comparing hypothetical value by the real numbers that we already. Okay, I was saying that maybe I think you hear me. Yes or not? Okay, others can confirm. Okay, others can confirm. Uh, for me or for Epaphroditte. Okay, so as I said, we have one sample. When we say sample, we have one interest, and then we want to confirm if our interest that we question ourselves, if it is really linked with hypothetical value. If I say hypothetical value, it's like a value that is that is in the mind of majority of people. That is the value that we have in our mind, that we assuming that we can assume that is true without having much fact. So that's why we go on the field and then we correct information to that value that we question ourselves, and then we use one sample t-test. The reason why one sample means that we focus on one group, we focus on one interest, and then we consider the hypothetical value and then the value that we get from the field, we get from the data that we have in a field. How we can do it? I generate the data, I generate the variable which is called the data, and then I assign that. Uh, um, I assign a random number like a 10, 12, 9, something like that. And then I want to confirm if the average value that I have here, if it is 11, 12, because in my mind, I have in my mind, I assume that the average, let's say that it's like a data, this is a product A, price of product A. Let's use price, price A. Let's say that this is the price of product A, and then maybe one day they earn, one day give us 10, 12, 9, 11, 13, 15, 14. This is the data. Let's assume that this is data that I get from the field. Then I want to confirm if it is the average price, if it is equal to hypothetical value that we have in our mind. That's what we have as mean. This is how we can write mean. You know how we can do inferential statistics. Those who knows how we can compute it by hand. Those who have a background in statistics. So and then what we do, we use t-test and then we put the variable name. I type it as a price. Sorry, I want to type it as this price. Okay, price, price A, price A. Okay, and then if I run, I will consider the p-value. If I see that the p-value is less than the level of significance, I take decision. I will confirm that. If we did, the null hypothesis says that there is no difference. There is no difference between hypothetical value and the value that we get from the field. And if we see that if we reject another hypothesis, it means that there is a difference between hypothetical value, that value that we have in our mind, with the value, the result we get from the field, which means that we have enough evidence based on the research we made to say that the average price of product A is different from what we have in our mind. That's how things can be explained. From that, I can run, and then if I run this, see what happened. You know, one sample t-test, you see p-value is equal to 1. If p-value is equal to 1, it means that the alternative hypothesis true means is not equal to. Okay, so okay, okay. Based on this, if we consider the p-value, we see that p-value is equal to 1. It means that since p-value is equal to 1, there is no relationship. There is no difference. Not say that there is no relationship. There is no difference between hypothetical value and the data we get from the field. So another thing, it's like saying that the mean price is equal to 12. Then okay, yes. You guys, for people who using chat, I didn't see any chat. Just try to speak. If you don't speak, I didn't hear you, and you disturb me, because when I'm projecting, yes, 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 okay, yeah, thank you. Okay, this is 6 month of data science program, started in February 2025, organized by EduConnect Rwanda, as you see. And then it was mainly started in February, as I mentioned. It is expected to end in August. It was supposed to attended by people who pay for that program. So I don't know how you enter in a group of other specialization, because we are in the last phase of or advanced stage where people they go on the show by show. We started by running introduction to statistics, and then we continue to data, we continue to introduction to R and Python. And what we are doing here is like doing advanced stuff by using R. There is another guys who is throwing Python for data analysis, but it's okay. You can join us today if you be happy for that. But other than that, you can ask a CEO to give you authorization to join this class next. That's how things works. Okay, thank you. Let's have like a calls to uh let's have this session today, and then type me in box. I'm in charge of that. Type me and I will tell you more. So maybe it was our fault to not explain you much. But I was expecting that those people who is in that group you already knows what happened. But it's my fault. Type me in box. I'm Tastier and I'm the one who sent the link to join. Just we will have a look. I will see how I can guide you because we have other program that is going to start for doing those kind of things. Yeah, yeah. Okay. Continue to sample t-test. It's like we have two groups, and then we want to compare if those two groups have the same similarities, just in terms of numbers. One sample t-test, two sample t-test is for both for numerical data. So maybe I have product A and I have product B, but I want to confirm if product A and product B gives me the same price on average. That's why I use two sample t-test to test if two independent group. If I say two independent means that there is a difference, there is no relationship. I have product A, and product A is made by a certain things, and then product B is made by another thing which is different from what is made by product A. And then I want to see if product A and the product B has the same similarities or has the same price on average. That's why we use two sample t-test. And then if we run, we will see. And all of those tests to confirm if it has the relationship or not, if it is the same or not. Remember, the null hypothesis says that there is the same. There is no difference between group A and group B. But for hypothesis or for alternative hypothesis, always comes by saying that there is a difference because for us it's always opposing hypothesis, we opposing null hypothesis. And remember that in null hypothesis it says it is a true, it says that there is no difference. And for us we confirm that there is a difference, because if there is no difference, there is no way of doing a research. We want to confirm that these things are the difference. And then what I can do, it's like to run. If I do t-test and then I put the first variable, second variable, and then value dot equal dot true, it means that mean are equal. That's how code works. You need to change it. So what I do, it's like to consider the p-value. If I see that the p-value is less than 0.05, you see that it is less than 0.05. So I confirm that there is a difference between group 1 and group 2. So another thing, it's like pair the t-test. So the purpose of using pair t-test is to test if there is a difference between mean before and after treatment. Maybe I can have a product A, and then I sell that product to the first stage, and after selling it, I realize that there is some the new thing which is missing, so that I can make my product A better. And then I go and update it. After updating it, I will put it on the market again and I sell it. And then from that, I want to compare if the ingredient that I was using for the first time before I update it gives the same reward as the product I update after adding something like that. I want to compare the before and after. I add things before and then I want to compare it after. That's how we can do those kind of things. And pair the t-test, it's one of the tests that can help us to compare before and after. And most of the time, these things works in project management. So the reason why I'm saying this, it works in project management, is because in project management we base on We have what we call uh, result-based monitoring and evaluation. So we consider the result when we are going to initiate new program. We need to have baseline information before we start intervention. What is the current status? That's what we can say as before. And after making intervention, that's what we have called after. After making intervention, what is the result that we are receiving now? So when we need to compare the current before intervention and after intervention, we will use T paired T test, paired T test. And then we consider p-value to see if the result we have before making intervention is equal to the result we can have after making intervention. So that's how pair T test works. So what we do, it's like run and then consider the result. So the only thing that you need to have in your mind, it is just to understand. It is just to understand how it can work. In these detailed default before and after, data are essential content. Okay, I don't know the problem. Okay, let's see this. Okay, run this and then show me. Let's debug. Okay, why? 1, 2, 3. So why this? Okay, constant. Can I increase? Let's see if it can work now. And then I explain. Yeah, yeah. You see, the reason why I was receiving an error that the data are essential constant. It means that there is no change. While we are seeing that there is the difference, but the other they understand that there is no change. That's why we see this error. It means that the data we have before it is the same as the data we have after. That's why the code was not running. But I tried to increase the numbers like 1956 2106 so that I can see. And how we can take decision, it's always look at the p-value. And if we see that the p-value is not less than the level of significance, it means that the result we get before and after are the same. Because the null hypothesis says that the result you can get before and after, it is the same. And for us, alternative confirm that the result we get after and the before, it is a difference because of the reason. Maybe as I said in project management, because of intervention we made, the price was increasing. Because of the intervention we made, the max was increasing because of the reasons. Maybe we do intervention so that we can handle some problems. And the reason why we implement the project, it's like to answer some questions that is already there. And then that's why we need to have basic information as what we call before, or in a language of project management, we can say that is a baseline. And then we need to have the result we get after making intervention. So that's why we need to use T pair T test to confirm. And remember that those things, it can work for numerical data. And then when we are trying to do it for dummy data or categorical data, so it's a bit advanced. We can use randomized control trial, something like that, or we can use another advanced model which is called like you can go and search what you call difference in difference model, or you can work for uh, propensity score match. That is a model that can model a certain data type, data type, a certain context. But for us, let's have in our mind that we can use pair details for that uh, condition. And here, chi-square for independent. I'm not going to repeat chi-square again because chi-square for that kind of things. You know how chi-square should be works. It's consider the categories. Consider if there is a relationship between categorical variables. The only way it's like chi-square dot test, and then you know that they says that there is no relationship between category A and category B. And I was trying to generate the matrix, which is made by three. If I run this is made by three variables. I think you will see how those things should be what if I run this. Sorry for that. If I run this, you know, this is variables made by two. It is made by two variables groups and the responses. Yes, no, something like that, those kind of things. And then for me, what I need to do, it's like using chi-square to confirm if if those groups, group one and their responses, they can respond to that variable if they respond the same answer. So that's why we use chi-square for testing if two categorical variables has the same result. So if we consider all of them, as I said, we consider the p-value. You see the p-value, since the p-value is less than the level of significance. So when I say level of significance, majority or by default, we understand that the level of significance is an error that it's like a standard error that we are allowed to make if we follows the standard procedure. What is an error that we can make like by default, because we are human, we are not doing things properly, but there is an error that we can make by default. So that's why we need to know it. Not always that the level of significance always should be 0.05, but it can change. As I said, in the field of life, or we can say the 99% of what we are going to provide, it is true. And I think Epaphroditus knows the 5% in life. It's like a bit, it's like a big number. So that's why when we are analyzing things which is not related on making experiment, mixing chemicals, by standard we use 95% of what we are doing is true, and then we assume that the remaining 5% it's an error that we can make. That's what we call level of significance. But most of the time we will see that 0.05 comes in your mind. That is the only reason. But when you are going to the scientific things, you need to increase the confidence interval. If you increase confidence interval, it's like assurance of the result that you are going to provide. And if you increase confidence intervals, it means that you reduce the level or of significance. You reduce the error that you can make. You reduce the error that you are allowed to make. That's how things work. So, and then you remember that you always consider the level of significance in every decision that you can take. And from that, it is ANOVA. I think Mr. Benoit told about ANOVA. It's like ANOVA compare to It's compare to more than if we use ANOVA when our dependent variable is numeric. Our dependent variable is a numeric, and then do we have independent variable which is categorical. So we want to know to what extent our categorical variables contribute to dependent variable, but for each categories. Let's say that we have category A, B, C, D, and then we want to know to what extent average contribution of each category to our dependent variables. And we have seen that we use ANOVA even if we have multiple independent variables, which is categorical. And then we want to understand each contribution of that categorical variables. And in each categorical variables we have, in each we have sub-variables, we have subcategories. We need to understand their contribution of subcategories in each variables to the dependent variables. That is only reason why ANOVA comes. Analysis of variance. As I said, if we say analysis of variance, we need to understand the variation of each categories to the numerical data that we are interested to express. That's how ANOVA works. And then what we do, it's like printing ANOVA, we do over, put the dependent variable and then put independent variable. If we have another variable here, let's create another variable and then put it as a price, something like that. So that I show you to add more. You see, we have seen that we use data C, something like that. Let's add another variable and then we will see how it can work. So to add other variables, you see this is dependent variable scores, and then this is independent variables. To add other, so I put the plus and then put another variable here. So if I run, it means if I have more, I will put plus and then continue. So the range difference found in price. So I will make sure that each observation is equal. If I have one, two, three, four, five, six, I will make sure that in the all variables has the same observation. Otherwise, they cannot work. One, two, three, four, five, six. And now it can work. So I will make sure that each variables has the same observation. If not, it cannot work. You see that now it is working. If I print summary statistics, you see. And how we can take a decision, we always look at the p-value. So this is the p-value, as you see. This is the p-value here in this context, and this is how you can interpret it. So from this, there is no relationship. From this, there is no relationship. All those variables that do not have significant contribution to our dependent variables, either between or within. So another thing like linear regression. So the purpose of doing linear regression to model and assess the relationship between dependent variable and one or more independent variables. So we use regression analysis. So when we have one dependent variable and one independent variable, it's what we call linear relationship. But if we have one dependent variable and more than one independent variable, and remember that all those variables, either dependent or independent, should be numeric. So we use we say it is a multiple regression analysis. So what we have to have in our mind, it's like having in our mind that regression analysis deals with numerical data. So there is no categorical data that we can look for. That is the only difference we can look for. So another thing that we can look for, I think it's enough for a linear regression. So we generate the variable which is called x and another which is called y, and then we put model, like a name, and we put rm. This rm is for linear regression model. So and then if I run, what I can do, it's like to run these variables. If I run this, if I run this, if I do summary, this is how model should be looks like. So we started by mentioning dependent variable and add independent variable. And to add more, for example, I can add more. Let's create another variable which is called z. I can add more. I make sure that I create 5 observations so that I can avoid the missing, something like that. If I run this, I can add another variable, another dependent variable here by putting plus and then put z. If I have another, I can put plus and add it. That is how we can add it. Let's say that I have another g which is called uh 1 2 2 3 4 6 9 0, something like that. Let's have it as this. If I run this, and I can add other variables that I generate which called g here. If I do this, that's how we can add the variables. So if I run, it means that I have 3 independent variables. I have x, z, and g. So if I run the code, I will see. So what you need to have, it's like to know how things works and then understand the concept, and then you will replace it. You see, this is the intercept, the value of y if we don't have x, z, and g. That's what we call intercept. And then you can consider the to confirm, you will see the p-value. If you see that the p-value is less than 0.05 as a standard, you see that there is a relationship between x and y. If you see that there is a relationship between z and y, and you see this star, what this star is indicate. So you see, if we have triple star, it means that we can say that it's like excellent relationship, excellent contribution of that independent to the dependent. For example, if we have double star, we can say that it is very good contribution of that variable to the dependent. If we have one star, it's like we can say that it is a good contribution. All those stars, it's like show us the extent, like deeply extent, where we have zero p-value. If we have zero p-value, low p-value, it means that that variable has much contribution to the dependent variable. So that's how we can see those things works. Yeah. And then after looking the p-value, you will go to see the for every unity increase, those kind of things. For every unity increase on x, y will be increased by 0.93. For every unit increase on z, y will be increased by 0.64. So there is no way to include the g because it is not statistically significant. So that's why you need to focus on the p-value before doing anything. And then remember that in our hypothesis says that there is no relationship between dependent and independent. So that's why we need to confirm if it is the relationship between that variable. So and another thing that I want to talk, it's like correlation analysis. Correlation it establish the relationship, show us if it is a positive or negative or there is no relationship. Just without saying to what extent as a regression. So and then correlation it is for numerical data, as you know. No correlation it is for numerical data, as I said. So and then here I was trying to, you want to measure association between continuous variables. If we say continuous, just understand it is a numerical numbers. So to see the correlation, it's like positive relationship. It's like the direction of the contribution of dependent variable to the independent variable. If they contribute to the positive way, if they contribute to negative way, if if there is no contribution. So to know that, it can help us to interpret better regression analysis. And then for us, if we see that they contribute to the negative way, on the coefficient we will see negative sign. So to run the correlation, we will run this code, and then we see what we do. It's like always consider p-value. That is how it can work. It's always considering on the p-value. It's always considering on the p-value. That's how things should be done. So I think from that, I add the code for doing visualization. It's like a bonus to how you can plot simple regression result. When you have this, you can generate simple regression result by using this code. I think it will work. And I was waiting for the reason why I didn't see the result here, because this size was too short. So I need to increase it in this way, and then I will repeat the same song. So if I do this, so I don't know the problem model. Okay, okay. Let's do the, because this is not simple. Let's remove this and then do the simple. If I do this, I will explain you more on that. So I don't know the problem, but it can work. Okay, okay, okay. Let's plot. Sorry, let's plot this and then control enter. Error on this. A ggplot. Sorry, I didn't learn ggplot. So to run it, it's like library dot ggplot2. As you see, if I run this ggplot, and then if I run this code for plotting simple linear regression, I will see it is now doing. This is how linear regression should be plotted by using Stata. Sorry, by using other programming. I was mixing the software, so sorry for that. This is how linear y and x, how we can plot it. So, but I think at least you get the logic. So we will have a project that is going to involve all those kind of things by using real data. So I'm going to find the data that we can use by searching the data which is appropriate to cargo, or even we can do dummy coding of our own data. I don't know if you know how we can do random data set by using R, but we will find the data which is appropriate so that we can refer to that data, so that we can perform that test in order to relate it in real world things. I was just having to introduce those kind of things before, and then we are going to do it by using a project. And I request you to continue to update your reporting, to adding some features which is advanced, doing better, asking me where you are stuck so that we can see how you can provide a good report. And then tomorrow we will learn how we can push our work to the GitHub, even how we can document GitHub in general. So I will show you how we can do it. Try to do the coding, so that try to prepare the stuff you can upload so that you can push on GitHub. Try to do better thing you can put on LinkedIn. Tomorrow we will have a session that is related to that context, and the some problem that you face while we are trying to finish your reporting, while we are trying to make a practice of what we have run, something like that. For me, I think that was enough for today. If anyone who has a question, maybe you can ask a question So if there is no question, so maybe can say that let's call it a day, uh, or can say that let's meet tomorrow. But if there is someone who has a question, maybe ask your question so that we can see how we can handle that problem. Relate things called the model and inferential statistics. Okay. Yeah, thank you. The models come come as to confirm. You know, if we say inference, it's like based on the information we have to take decision. And when we say model, what is model? It's like a model. The model help us to take complex scenario and put it in a way that we can understand it. Put it in a way that we can help us to, in a way that we can have a rule to explain that complex information. And then we use model to simply understand complex equation so that we can, based on the how model is built, as I mentioned, we have a lot of model. For example, if we say that linear regression model, that model it is designed for understanding complex numerical data. If we need to explain something based on something, we use which is numeric, we use regression model as multiple regression model. And then based on that result we get from that model, we can take a decision on what will be happening in future as a part of inferential statistic. I don't know if you understand it, but I can put it in Kinyarwanda. So iyo tuvuze modo, uvuga ngo modo idufasha dufata bya bintu biri complex, hari scenario dushaka gusobanura iri complex. Modo rero idufasha kugira ngo twandastandinge ibyo bintu biri complex. Like ndashaka gusobanura price nifashishije variables ziri numerique zitandukanye, nzakora regression model. Bivuze ngo ninjya gusobanura njye ndajya mvuga ngo wenda 50% byo kuba igiciro cyarazamutse byatewe n'iyi variable runaka, byatewe wenda na number of suppliers batuzaniraga ibyo kurya n'urugero. Urumva ko iyo scenario kugira ngo ngende nyivuge mu magambo ntago biba byoroshye gukonvisinga abantu kugira ngo babashe kuyumva. So that's why we need model to model that scenario. And then after getting the insight from that model, we based on it to make inference. Inference means to make decision. That's what we call inferential statistics. It's based on the model result and then predict what happened in the future. So I don't know if you get it. Okay. So if we say majority of inferential statistics that people knows, it is for parametric. Parametric, it knows that before doing any analysis, we have to know that our data follows has a distribution that follows. If if the data is not normally distributed, we go back to the non-parametric. Of course, parametric method, it deals with data which is normally distributed, the data that is corrected for the people who has same characteristic, let's say something like that. And then if I have the information which is corrected for the people who are different in culture, for example, if I correct information from the people in Rwanda, and then other information I correct the same information for people in US. Those people, due to the concept that I'm trying to express, they have the different similarities, for example, on that context. So for me to better understand or to better analyze that scenario, I will use non-parametric method, so that non-parametric method tell us that why we are trying to do this, but we are sure that this information we are going to analyze, whatever it is the same, but the respondent has the difference background on that context, which means if you say that normal distribution, just understand that the respondent shares some characteristic on the question that was asking. But that's where we use parametric method to take decision. The parametric method, it is designed for the that scenario. And then for the scenario which is data is not normally distributed, it means that there is a some respondent they didn't share common characteristics. So that's why we need to apply non-parametric method, like the most of common non-parametric method. It's like what we call the Wilcoxon rank test. Uh, uh, I don't know much, but it's a more. It's a more Wilcoxon rank test of Wilcoxon log rank test, something like that. There is a lot of peer rank correlation, those kind of things. It's a somehow, yeah. No, I didn't want to. Honestly, I didn't want to talk it much because it is not commonly used. For to use like non-parametric, it's like somehow bit advanced. I can say something like that. Not necessary. Not is in common use. Not is used in common. We use it like on that sense, but we can see. I will show you some. I will explain you some non-parametric method as I mentioned with Coxon rank test, log rank test. Uh, I don't remember it the test, but I know some chi-square independent test, chi-square interaction test, those kind of things. There is a lot of things that we cannot cover here, but I know it is exists because non-parametric method, you guys, it's like a module of 15 credit. And to say inferential statistic, most of the time we use parametric method. That's why I focus on much. Even on inferential statistics, we cover like 10%. Let's say something like that. We cover like a 10% of parametric method. Statistics is much more. Do practice and then you will learn much more. There is a lot of model you don't know. Even me, I don't know. But doing much practice, you can understand the data you have, they direct you the test you are going. The data you have, they direct you the distribution that you are going to follow. Remember that. Remember that scenario. So for us to decide the distribution that we are going to follow, the analysis that we are going to do, the model that we are going to do, it's all about understanding the behavior of our data. So that's why everything that we need to do here, it's like when you are trying to do like model, try by starting checking normality by using Shapiro dot test. I didn't do it here because I know that you know how to check normality. But the reason why I do this is like showing you how you can do those differential statistics, but I didn't go in deep to make much protocol for doing differential statistics. But always when you say that I do ANOVA, question yourself, why do I choose to use ANOVA? That's how things should be done. But honestly, there is a much more than parametric, but also for parametric, because I can say that we cover only 10% of what we have in parametric, because we have a bit for people who are in the field of health. They don't use the same inferential statistic for people who are in the field of finance. They don't use the same information for people who are in the field of hospitality. They don't use the same information for people who are in project management. There is a huge inferential models in all contexts. That's what I can say. But you have to know what It's right. You have to know basic so that you can base on that to search more. Um, so I think if there is no other question, so we can say that let's have a good night and then continue to work on that project, and I'm going to send you the data set we will use in this coming week to focus on inferential. And then remember, tomorrow we will know how we can use GitHub, LinkedIn to push our stuff. Try to document everything that you want to push on GitHub so that tomorrow we come as we are ready to push all those things. So let's have a good night.